looking at common factors of a polynomial. This is textbook section 3.3. So looking back, we can find the greatest common factor of numerical terms by factoring them out. So if you made the factor tree for 12, 8, and 20, you would get that 12 is equal to 2 squared times 3. 8 is equal to 2 cubed, and 20 is equal to 2 squared times 5. So the greatest common factor between all three of those numbers is the number they have in common with the highest exponent they all have in common. So that will be 2. And the highest exponent we can get where they all have in common is squared. So the greatest common factor is 4 for each of these terms. When we're looking at polynomials, we're doing the same thing with the coefficient in front. Okay, we are factoring that coefficient and finding the greatest common factor that those two coefficients have in common. With the terms or the variables, we are going with the highest exponent they all have in common. So I factored 12 and 30 just so we could look. You can always try dividing by things you know, but I'll show this example first. So 12 is equal to 2 squared times 3, and 30 is equal to 2 times 3 times 5. So the greatest common factor between those two numbers is 2 times 3, so 6. Therefore, I can divide both of these terms by 6. And I can divide both of them by an x. X to the power of what, though? So we have 12x to the power of 7 and 30x to the power of 9. So what they have in common, the greatest exponent would be a 7. Therefore, the greatest common factor is 6x to the 7. Now, you don't have to factor the numbers out. You can just start trying to divide. So I could divide each of these terms by 5. That's an easy one to look at. The x term, the greatest x they have in common is squared. So greatest common factor, I think, is 5x squared. What we can do is divide them out. So 15x cubed divided by 5x squared is 3x. And the other one, 20x squared divided by 5x squared, we will get 4. So I can't divide either of those coefficients by any more numbers, nor can I reduce their variables. So I know that I have found the greatest common factor, and that is 5x squared. Trying our last example here, 14 is only divided by 2 and 7. So if I tried to take 2 as my greatest common factor and divide 21 by that, I couldn't. So I'm going to divide by 7. And then each of these terms has an A in it, and each of these terms has a B in it. So we just need to decide what the greatest common exponent they have for each one. So 14a cubed, 21 to the power of a, and 35 to the a6. Therefore, the highest exponent is 1 for a. For b, we have a b squared, a b to the 4, and a b squared. So the highest exponent they all have in common is b squared. So 7ab squared is what I could divide all of those terms by, and that will be our greatest common factor. So again, it's just like we did for numbers, and the only difference is we're dividing by the greatest exponent they have for each variable as well. When we write a polynomial as the product of factors, we factor the polynomial. It is the opposite of expanding. So we are looking to start decreasing our polynomial, if you will, or dividing by things they have in common in this case. So we are going to factor out the greatest common factor for all of our polynomials and write that as a multiplication statement where our greatest common factor will be multiplied by the rest of our polynomial after it's been divided out. where if I expanded it back in, it would equal the original. So let's find the greatest common factor and factor the expression. So between in A, we have 3g and plus 6. So the greatest common factor is 3 here. Okay, so that means I could divide both of these terms by 3. So this will be equal to, all right, let's divide each by 3. Our greatest common factor goes in front, and what is left from our division statement goes in these brackets here. So 3g divided by 3, we are just going to be left with g. 6 divided by 3, our next term, is going to be 2. So 3 times g plus 2 is still equal to our original statement of 3g plus 6. We can double check by factoring that out or expanding that out, sorry. So double check. And we get 3g plus 6. So we're going to do the same thing for b. The greatest common factor, I can divide 8 and 12 by 2, but that's not the biggest number I could divide them both by. I can divide them both by 4. Now they each have variables attached, so we could divide by a d. 8 has a d to the power of 1, 12 has d to the power of 2. So the greatest one that they have in common is d to the power of 1. Therefore, I'm going to divide each term by 4d if I am factoring a 4d out. So I'm putting 4d in front, and what is divided out is left in those brackets. 8d divided by 4d is 2. 12d squared divided by 4d is 3d. Again, you can check by expanding these out. 4d times 2 is 8d. 4d times 3d is 12d squared. So our greatest common factor goes in the front, and we are multiplying by what is left of our division statement in those brackets. Okay, I'm just quickly going to do these. What I'd like you to do is pause the video and factor out the greatest common factor in each of these and double check your work. So in A, the greatest common factor looks to be a 2. There's no variable on 6, so I can't divide by a z as well. So 2 out front, I'm going to divide each term by 2. I'm left with 3 minus 6z plus 4z squared, just dividing those coefficients. In B, the greatest common factor is 6x. I'm going to go ahead and show you what happens if I'd only divided maybe by 3x. Okay, maybe I missed what my greatest common factor was. I can recover from that. So I'm going to divide each term by 3x. And I'm going to be left with 3x times 6x minus 4 plus 8x squared. Now, if I look at these terms here in my bracket, they can all be divided by 2 still. Therefore, I need to take out a 2 as well. So I'm going to have 3x, my original greatest common factor, times my new greatest common factor of 2. And I'm going to divide everything in that bracket by 2 as well. So 3x minus 4 plus, 3x minus 2x, minus 2, oh my goodness, plus 4x squared. So now I cannot divide 3, 2, and 4 by any factor. That is all. So I have 3x times 2 out front, so I'm going to say that this is 6x, 3x minus 2 plus 4x squared. So if you originally divide by a number like we did 3x and realize it's actually not the greatest common factor, you can just keep dividing until you cannot divide anything out anymore. Okay, and those terms just get multiplied at the front and become one greatest common factor. Factoring with more than one variable, we're just going to take out more than one variable for our greatest common factor. Okay, so in this case, our greatest common factor is 5xy. So I'm going to divide each of those terms by 5xy. 5xy goes out front, and I am left with 2 plus 3y minus 4y squared. Again, we could double check our work by expanding out our monomial times a polynomial to see that we got the exact same answer as we started with. Jasmine factors this polynomial. Identify her error and write a correct solution. So this was our original polynomial. And Jasmine's answer is 2mx times 4x plus 6 minus 2. So first off, Jasmine could have taken those two terms and added them together, but I don't think that that's the error. Again, how I solve these problems is I go through and solve them and then double check to see where this person has gone wrong in their answer. So the greatest common factor between 8, 12, and 4 is 4. And the variables that they all have in common, they all have an m in their term. However, 8mx squared has an x. We have an x here, but there is no x there. So our greatest common factor is just 4m. What's left behind if I divide the 4m out of each term is 2x squared plus 6x minus 2. Okay. Oh, sorry, minus 1. Oopsie. So, looking at Jasmine's answer, what she had for her greatest common factor was 2mx. So first off, Jasmine could have factored out a 4, not a 2. And she's also got an x in her term. So the greatest common factor was 4m, not 4mx. All right, the surface area of a square-based pyramid is b squared plus 2bs. That was written interestingly here. Write the formula in factored form. Use both forms when blah, blah, blah. Okay, let's do A first. So write the formula in factored form. So this common factor in the surface area, b squared plus 2bs, is b. I can divide both terms by b. So b plus 2s will be in my factored form. Use both forms of the formula to calculate the surface area when b equals 5 and s equals 4. So for b, let's use our factored form and sub in. So the surface area equals b, so 5 centimeters, times 5 centimeters plus 2 times 4 centimeters. I get 5 centimeters times 5 centimeters plus 8 centimeters. We get 5 times 13, it looks like. And I get 65 centimeters squared. If we use our unfactored form, or original, we can sub in surface area equals b squared plus 2bs. B was 5 centimeters. This is all squared plus 2 times 5 centimeters times 4 centimeters. We get 25 centimeters squared. And 2 times 5 is 10 times 4 is 40 centimeters squared, which is 65 centimeters squared. So what is the same about each surface area you calculated? Well, they're identical. And what's different about each surface area you calculated? Really, just the way we got our answer. Okay, the formulas are still the same, they just look different. Okay, What are the dimensions of a rectangle with area of, oh goodness, this looks funny the way it's inputted. Sorry, gang. I'm going to rewrite that for us. So area equals 52 x to the 4 y squared plus 60x to the 6 y. So area is a length times a width. In our case here, we just have one statement. There's no multiplication happening here. So we want to factor this so that something times something equals this area. Okay, so we need to factor out a greatest common factor, and the rest, the remainder, or the rest of our division statement will be there. And the greatest common factor will be a length or a width, and the remainder will be the opposite. So the greatest common factor between 52 and 60 is 4. Okay, you could divide by 2 first and see, and you'll know that notice that you could divide by 2 again. That's okay. The greatest x exponent they have in common is a 4, and the greatest y exponent they have in common is a y. So 4x to the 4y. So our area will be 4x to the power 4y. Now we're dividing each term by that. 52 divided by 4 is 13. Now dividing our exponents, x to the 4 divided by x to the 4 is kind of what that will look like. Remember, we're dividing each term. Our x to the 4, take away x to the 4, we're left with no x. Y to the power of 1. Now we're dividing this one by 4x to the power of 4y. So plus 15, we're left with an x squared and no y. I cannot factor 13 and 15 anymore, nor are there any variables in common. So the length of our rectangle could be 4x to the power of 4y. Whoopsie. Y should not look like an exponent there. And our width could be 13y plus 15x squared. Okay, because when I multiply those two terms together, I get the exact same area. Exit task, go ahead and pause this video and check your answer afterwards. So the greatest common factor between all of these terms is 3xy. Therefore, my final answer when I factor it out is 3xy, 7x squared plus y plus 11z. Sorry, that should have been a z there.